Okay, so to use what equipment we use here. So good morning. It's actually a day for the programmers like us. So good afternoon or good morning. Today I will be doing some introduction to TensorFlow, understanding the concepts and the depths of the TensorFlow machine learning framework. Now, uh, I think we should just start right away. So let's just go. So this is there are a lot of results like it's GitHub, it's Wikipedia, all that. So let's just go to the website. This is the website. Yeah, this is a very like it's a very decent website, very intuitive, very interactive website. So uh, this is a core open source library to help you develop and train the ML models. And we can get started with TensorFlow using the Colab notebooks. But I think I'm going to run and do some tutorials on my Jupyter notebook, and after that I will just start by I will give you the links of the public links of these notebooks. Actually, you will be understanding the concepts. So the links for these have been given in the description. So let's just start. This is the end-to-end open source machine learning framework. It has model building, robust ML production, like building ML pipelines and all that, and powerful experimentation for research. Right? As it is it is an open source library. So it is there are many experiments going on there. So releases and new versions get out. So for here we have some tutorials and videos and connecting then the companies which use them, announcements, new announcements, and this is community support. And then that there are resources. Now these resources are like where we can find like for the JavaScript version we have resources, for that we have models. Here we have no gardens in place. Here we can get models and examples. Here is TensorFlow Hub, very recognized library. TensorFlow Hub. TensorFlow Hub, where we can get the pre-trained models downloaded and we can work on them. Then we have datasets, official datasets, Google research datasets, and other datasets. Then we have tools. We have some tools like Colab, TensorBoard. TensorBoard will do some on the converter tool, Playground, where we can play in neural networks and weights and bias. These two and these four are a bit advanced, deeply research cloud and all that. So we will do that afterwards. Then we have some libraries and extensions, like we have TensorFlow Hub, then we have recommenders, then we have graphics for computer graphics, then we have model optimization, optimizing all that. If you know what is optimizer, this library is for optimizing machine learning frameworks, a TensorFlow model. That is probability, tensor, all those things. And not just about TensorFlow machine learning, there is quantum machine learning, quantum computing. So TensorFlow quantum is also there, and data streaming and pipelining systems, TensorFlow IO, well, all that. Then decision trees, decision forest trees with TensorFlow. The API is like we have versions of the latest is 2.6. Then we have all these versions from R with TensorFlow 1, but at this time we use TensorFlow 2. TensorFlow 2 is a bit more advanced. TensorFlow 1 if we needed to use the GPU, then we had to use some special aspects. Now here we need to install a separate package for TensorFlow GPU, but in TensorFlow 2 It comes with CUDA and CUDA support. So I think I should not actually, because its installation is a bit. I've done a bit advanced type of installation, like using PIC and then using GPU support. But instead of that, you can just simply use, if you don't want to run on your personal computer. If you want to run on a personal computer, then you have to follow the steps of GPU support and all those things. GPU, you have to install CUDA and all that. Let's get in some other yeah, simple that you have to install Python with pip. Using pip install Tensorflow, and it has different styles, like different operating systems using Ubuntu, Mac OS, Windows, and other systems. Then we have using virtual environment and pip installation, package installation of 3.9 GPU support and all that. These are the wheel files for that. Then we have TensorFlow GPU support. For that, you need to understand the hardware requirements of the graphic card in your computer. Then you have to install CUDA. Then you have to do CUDA toolkit. You have to install with the like here it is go to this Windows and build from source in Windows. You don't have to read all that. If you want to install the latest GitHub repository version, then you have to understand these things. You have to install the dependencies. Then you have to install using VC, C++, C++ build tools, then GPU support and all that. But come down and you should find tested build configurations. Here, what it is that it gives you what type of GPU you require, what type of versions you require for the latest version, like the TensorFlow GPU 2.6, like it has the requirement of CUDA 11.2 and the CUDA 8.1. I have installed these. Now you should also, like they are also language binding Java, C, and Go. It is available, but JavaScript is available. So these are all for that. You can use Pip. You can also use Docker. Build a Docker which contains TensorFlow. Or the simplest version of them is like don't use on a local notebook, local Jupyter. Use as we are going to use Jupyter notebooks. So you can use the online Jupyter notebooks. That is the Colab. Colab. This Colab version. Okay. This Colab will help. It contains pre-installed. It has pre-installed version, like here it is. It has pre-installed libraries, and you just need to go through it. Like there are data science libraries, data science, then machine learning examples, machine learning, all those things. You can use this. Okay, it's a very good library. So after that, I'm sure so if you want to be in tutorial now. Okay, to introduction. Now, when we talk about introduction, there is like TensorFlow. For JavaScript, we have TensorFlow JS. For using TensorFlow models and in using React Native or websites, the TensorFlow JS. For Android applications and embedded systems, we have TensorFlow for mobile and IoT. And for production, like building pipelines and cloud-based systems, for that we have TFX extended. Okay, so this is something like reprocess, or what do we do with a machine learning model. Like for Python development, we have CPU, GPU, and something we call as a TPU. TPU, if you want to understand TPU, that is TPU. TPU is a tensor processing unit, tensor AI accelerator, hardware accelerator, like a GPU, but much faster than a GPU. Okay, So you can understand about that with this cloud.google.com version or a Wikipedia about tensor processing. So after that, it is like we have to load and pre-process the data and create input pipelines. Then we have to train the model using Keras or instead like Keras is a sub-module also, but it is a separate website also. This is Keras website, the Python deep learning API website. Okay, API docs and all that. It has all these things, and TensorFlow actually has all these things. TensorFlow simply uses the backend, the machine learning backend as Keras. So, and after that we deploy. Okay, so in JavaScript also we just use pre-trained models and we run them on different platforms. Then on iOS, these are the X devices. We simply use TensorFlow Lite, and then we have end-to-end production TensorFlow extended version here, and then we have some tools like TensorFlow Hub and TensorBoard. Okay, so up till now, I gave around a very brief introduction to what is TensorFlow, what are the feature aspects and all that. So now I think it will be a very exciting part to run through this whole open learning. We click on learn and then we go into TensorFlow. Now here we have for beginners, they have given a starter code for all of you to try in an interactive notebook also. Like this is a simple version of MNIST data recognition. Uh, See how much less the code is. You can understand from here MNIST dataset. We simply import from tf.keras datasets. Then we split the data and load at the same time. In sklearn, we did something else. We imported sklearn.model selection. Then we imported train.test split function and we split it. But here we simply do that, and then we do some for and list as we know we have to divide the data by 2255 float number. Then you create a simple sequential model. Sequential, we will understand what is a sequential model. This is a bit fair advanced, but we will go towards a little part. Wait a little introduction towards. We will start from tensor. What is a tensor? Then we will go on to model builder. Okay. Then we will try the tutorial also. Okay. So I want to go to guide. Now you can go to the documentation here. You can work on your own. Here it is essential documentation, install, migrate, Keras is with basics, then the data input lines, then we have the best practices, the performance, the accelerators, how do we do all that, and these are the libraries. So don't go through this will actually confuse some of you. So just try to start from here. TensorFlow basics. What is TensorFlow basics? Okay, we can start from eager execution. We can start, but actually, I don't think I should recommend starting from this. No, actually, I think you should. Tensor, yeah, Tensor will be a bit uh, suitable as we will be working on tensors. So, first of all, you can download here. You can run the Google Notebook. You can view the source in GitHub, and you can also download this whole notebook. Okay, so I'm going to run along. So I will just create my chapter. I'm creating the chapter notebook in this folder, and this is the chapter notebook. I hope it should be visible to everyone. Yeah, I think it should be visible. If not, I'll just increase the font a little bit. Yeah, that should be enough. So I can like I should rename it with insert introduction. Okay, so what is introduction to tensor? introduction to tensor. Uh, Tensors, it is given in the definition, tensors are multi-dimensional arrays with a uniform type, D-type data type. Okay, uh, if like tensors are simply multi-dimensional arrays. We have in Python, we have some lists, yeah, and we have then dimensional list within list. That is a 2D array we create array, and then we create 2D array. In NumPy we also did NP arrays, we created multi-dimensional arrays, and those multi-dimensional arrays are like this tensor but of particular data type. Okay, uh, there are multiple data types. We can open those data types and we can see what type of data types are there. Okay. TensorFlow D types to type. There are many data types. We can use the field source here. Actually, this is not preferable to use this much step. You simply have to understand that D types. D types is data types. In 32 float, bool, and all those things. Okay. We will go on here. So first of all, let us first of all import. So we are importing TensorFlow and NumPy. Now you have to understand something. Like we want to import the libraries. We can actually write in libraries. We import TensorFlow like this. The next thing is the basics. Okay. A scalar. What is a scalar array or a rank zero? So it means the right here. Basics. Right. Basics. I'm going to basics. So first of all, it is a rank zero or scalar. Okay, scalar tensor. A scalar contains a single value. Okay, we can write this. It contains a simple single value. Okay, if you want to like rank zero tensor, df dot constant zero, and you can print this. Let's see what it is. Now here, if we see rank zero tensor, it is a simple value. The shape is a single array, and then this data, it's simple. So what is it is a tensor, tensor, and a data type of 332. Okay. Now rank one is actually a vector. Okay. Rank one. Rank one is like list of values. So let's create a rank one tensor. And here we will see Here what we will see, 0.9, like I want this is values. Okay, it goes to 4 to the positive decimal unit. Okay, then we have what we call a RAM 2. Also called RAM 2 matrix. Matrix. Okay, you can see how what we has two axes. It has two axes just like numpy RAM 2 also is P of constant. And we are creating a constant matrix. So let's just create an array. Um, 3 and 4 and 5 and 6, and let's just give it um, let's just give it a float 32, and now let's see what we get. So we get a numpy array of float 32 in decimal points. That's it. And here we can see a matrix shape is like this, vector shape is a list, and these things. Then we can create multiple types of arrays with more axes, like this is a rank tensor. Okay, these are the dimensions. So its shape changes. Its shape, like here, its shape is 3, 2. Okay, we can create this is 3D array. If you want to 3D tensor like that, and here we can see something like into 3 layers. And if we print it, we get three different layers of two different layers. Okay, so after that, we get this is a tensor. Okay, now in TensorFlow, it gives us a very good thing to do. We can simply convert this TensorFlow tensor, TF dot tensor, into a NumPy tensor. You can convert this. Let's just convert the RAM tensor, and it is converted. Okay, and or you can use this NumPy or simple like this is C9. So we use this function and it automatically creates an array of NumPy. These are the methods. Then we have a different tensors. Tensors are often contains floats and integers, but there are many other types like strings and complex numbers like that or not. The base tensor classifies tensor to be rectangular, and which that is along each axis every element is the same size. Yeah, it has the same size. There are some special types of tensors like ragged tensor, sparse tensor, and all that. We can see that, but first of all, we have to go to the operations of tensors. Like what are the operations of tensors? You can do add, multiply, divide, like all those things, matrix multiplication and all those things. You can do all that. So uh, let's just create perform operations. tensor. Now a is equal to tf dot constant. Let's just create it. Now you can select that 1, 2, 3, 4, and 5 and 6. This is A, and if you want we can define the data type. Okay. Now I want a constant to be of 10, 10, 2 and 5. Clear this and let us know. 5 and 9. And if you want you can use that compatibility. And now print tf dot add a and b. And if we add them we get this. Then we see let me add a actually we can see matrix over there. And this is error. That is an input mismatch. Okay, we have got an input mismatch. Input mismatch. I don't think we did something better. But 3 and 2 and 2 and 3, yeah, we did matrix multiplication. It should give us an error because shape mismatch is happening here. Okay, shape mismatch is happening here. We have wrong shapes. So after that we have multiply a and b like this. So for this what we do, we can simply, if we want without as we start the a minus b, can do these. So okay, all kind of operations we can use, like you can use ML, use ops on tensors. Like I want to print reduce maximum of just to be constant. Or cannot convert the value of this. Yeah. Solve for that. Yeah, that is good. It is not the I didn't added them or didn't put them in a series and reduce maximum. Then we get tf dot and then dot softmax on C. The softmax function. Then we have the largest value from the largest value. Then we have shape, and we have seen the shape. What is shape? Then we have indexing. We can actually do this tensor We have almost quickly understood what is the tensor. Uh, Next, I think I would move on to indexing. Indexing is simply like in NumPy, tensors are also like index them. So rank 1 tensor, like we are given a rank 1 tensor, you can index with the scalar moves, like find out the first element in this array, which will be 0, then the second element, which will be 1, and from the last the element will be 34. This is indexing, positive and negative indexing. Then we have slicing. Okay. If you want, I can do this. This will print out it, and now what should it print out? The zero indexing will be the first element. The first, no, the one written will be this actually the second element, and likewise in -1 it is the last element. Okay, so it should print out these. Nice. Now the next thing we can do is slicing. Okay, you can understand by this output. It gives us a lot of outputs, like print everything. Everything will be simply a colon, then before the fourth element, print all of that. So that will be between the fourth index till the fourth index, 0, 1, 2, 3, 4. That is 5, 3, this 3 till that, print all of that. So and then from the fourth to the end, this likewise, and reverse will be colon colon -1. Simple. Okay, then we have multi-axis indexing. Multi-axis indexing is simply this, but using different a colon between a colon. Multi-axis indexing. Okay, a rank 2 tensor we printed here. This is the rank 2 tensor. We have to print out a single value. So how we will do that? A rank 2 tensor 1 on 1 numpy. This is a 4 on 1. That's how we do it. Then we get these operations. Like the second row, we have to print out the whole second row. That is a 1 and that all elements 1i. We actually understand a tensor by matrix. Matrix is 0, 0 from the start, and from the end it is depending on the shape. So that is we will iterate. Here the colon will be the iterator. Okay. After that, a third axis. Then we manipulate the shapes. We can actually change the shapes, manipulating shapes. We can understand. Manipulating shapes. Manipulating shapes is reshaping a tensor. Create a tensor constant with values like 1 and 2. You can do this, or you can create a single elements. Now let us print its shape. What do we get its shape? We get 2 as its shape, but we need 3, 1. So what we do, we simply this. But it doesn't work because we have to split between another. That is why it will create a 3, 1, a single elements and a single list. Okay, 3, 1. Now we will first, we can convert list. So we say x dot x dot shape as a list 1. Okay, then you can reshape it. Like I want to reshape it. Df dot reshape as 1 3, like that. And what I want to reshape is this. Okay, so print reshape this shape also it has printed out, like that. We can manipulate, change the shape of the pencil. Okay, and after that we can see we can flatten the tensor. Okay, flatten the tensor, like if you want to understand that what is flattening the tensor, the data maintains its layout in memory and a new tensor is created, the representation. Like we have to Tensorflow uses a row major memory ordering which in rightmost index corresponding single step. That is simply like what its in-depth version, what it does and all that. The rank 3 tensor, we will do a flattening of tensors. So let's just do flatten tensor. So first of all, let's just print a rank 3 tensor we created. This is the rank 3 tensor. We will flatten it. If we Because you have to understand something. I can see it uses a dynamic 20 allocation, malloc and calloc and all those things to allocate multi-dimensional arrays. Now in this also TensorFlow also it uses a C type version to allocate memory. Now if we have to see what is the representation of storing a multi-dimensional like a RAM 3 tensor in the memory, we can see it, we can visualize it using the flatten version. We can flatten it. If we flatten the tensor, we can see the order. We can see um, which order it is laid out in memory. Yeah. So let's just print out pf dot reshape, print out and a rank 3 tensor with -1 as its uh, axis or its reshape, and here it is. It prints out all the elements up till that a 30 single. Okay. So we can also reshape it with a multi-dimensional reshaping. Sounds a bit over complexed, but simply it is that like we can use a reasonable use of TF dot reshape when we did multi-indexing. We can also use multi-indexing in this multi-reshape, like combine or split adjacent axes. As there are three axes, so we can combine or split these axes. Like for into 3 into 2 into 5 axes, reshaping the 3 into 2 to 5 are both reasonable. These two are the both possibilities, so we can do both of them. Like first of all, the first will be tf dot reshape. What do we want to reshape? And tensor. And what we have, what we will read is 3 sorry 3 into 2 and 5. We can retest that and we get this 6 5. Yeah. And after that we can get a simple 3 minus 1 like this. Tf dot reshape, sorry uh, a rank 3 tensor with a -1, this 3 minus 1. You can get a single like a 2D array of all the elements in a single line. this is something we can get a bad reshaping. Reshaping will work for any new shape, the sum of total number of elements. Swapping, like what we need to do, like in NumPy also, swapping the accesses, like swapping one the row into another, it doesn't work. It will mess up the shaping of the whole array of the multi-dimensional array. Instead, we use tf dot transpose in that case. Okay. Okay. Uh, Now we get something like tf dot t types. What are TensorFlow data types? If you want, you can study on this from the documentation itself, because like you may run across not fully specified shapes. The shape contains a none axis, or the whole shape is none. We don't know what is the axis of the shape of the whole tensor group. Okay, except for the ragged tensors, we will understand what is ragged tensors below. Such shapes will only occur in the context of graph building APIs. Like there are neural networks or model building using graphs. That is the Keras functional API. We will discuss this further. Then we have data types. More on data types, like there are float 32 pointers. Then float 64 data types. We can cast them. uint 18. uint 18 now is also unsigned integer 8-bit. Unsigned 8-bit integer data type is it is for decimal precision. We can lose or gain the decimal precision according to the data types. Okay, now broadcasting. What we mean by broadcasting? We simply mean by broadcasting is increasing or decreasing a layer, like shape. Broadcasting, under certain conditions, smaller tensors are stretched automatically. Like there is a small array or a small tensor, it will be stretched out to a match or to a multiplication or some operation with a big tensor. Understood a bit? You can understand this more. Like first of all, let me just start by writing here broadcasting. Okay, broadcasting. Let's just create a tf constant 1, 2, and 3. Then we create while again a constant tf constant of like a simple 1 function. Then we get us another array of or another tensor of that. Now print all these are the same, all these do the same things, like multiply this by 2, we multiply this, and we can do is x and z, they all do the same thing. If we multiply x into 2, it will multiply element wise, then we x into z, it will also multiply the element wise, and then we get x into y also. That's the same. So we can reshape it, like what do we say, like x, there is a range function in NumPy. It is a range function. What it does is, okay, we got a range function it is. But here what we can do is reshape it given one, that x we can reshape it given one j, and let's see what it does. This is down, right? And y is tf dot range of 1 to 5. Let's see what is 5. 1 to 3 5. This is the error. Okay, now you can multiply x and y, and we get this 3 into 4. Done. Broadcasted. Stretched. Okay, stretched. Then we have converting to tensors. What we mean by converting to tensor, we simply mean that multiplication and all that, they are the class of a tensor class, the TF tensor, which you have to working on. TF tensor. These are the methods and the member functions of the TF tensor class. Okay. Now the next thing we are going to do is ragged tensors. What are ragged tensors? Ragged tensors are tensor with variable numbers of elements is called a ragged. Like variable numbers or variable different amount of numbers along the same axis are called ragged. Okay. For example, we have a tensor shape like 0, 1, 2, 3, 0, 5, 6, 7, 8. Its rows are clear. We have 4 rows, but its columns are not. Actually columns are not clear. One axis is not clear because there are different types. That is a ragged tensor. Okay, so you want to understand this a bit. Let's just try it. This is actually a great example to understand this very carefully. Ragged tensors, sparse tensors. This is a very great topic. Okay, ragged tensors. Okay, what are the ragged tensors? Like, you can create this ragged tensor. This is a ragged list. Now you can convert this into a constant. You can convert this into a simple thing. Like, let's just try converting this into a tensor. TF dot constant ragged list. Let's just see what it is. It gives us an error. Okay, what it gives us? Error. It gives us a value we can't convert non-rectangular Python sequence non-rectangular, non-regular to a constant. For that, its solution also TF dot ragged dot constant. Now convert to a ragged list. Now this is the ragged tensor. 0, 1, 2, 3, 4. Exactly what would different shape. If you want to convert its shape now, if you see, this is a list. This is tensor. Now let's just try to see its shape. 4 and 9. It's not the same, but we can now use this as a tensor shape. Okay, we can use this now. Now, next we have the string tensors. There are string tensors like vector strings. These string tensors can be next used for NLPs and all those things. String is just another key type, which say can be represented as strings and tensors. Strings are atomic and cannot be indexed. The way Python strings are, the length of the string is not an axis of the tensor, and so we have to use tf.strings to manipulate. Okay, so let's just see. Let's just see the scalar. uh, string tensor. Okay, tensors can be string. Here's scalar string tensor. Here, and we have vector tensor of them. Cross strings. Next, okay. Color emojis. You can understand these things. Don't remember. If you have to convert the string first, then we have our string to number variable. You can split the text and all those things. Right? Decode the byte. You can use cast, turn. You can actually use cast. You can use bytes. For that you have to use df.i. You can convert it to characters. Bytes, byte strings, we have strings, byte split. Now we are adding let's just see ints or ASCII values. The ASCII values like 5 ints. We have got decode. You can decode code from is sparse tensor. Sparse tensor, like in tensor, we have a scarce type of data, like we have a lot less data, only a few things, only few what we say indexes are filled with data, and this we have to store this operation. We have to do some operations on this type of tensors, and this is what we call sparse tensors. Okay. So sparse tensors, they store values by index in a memory efficient manner. Okay, and we can see this memory efficient manner. All the spaces will be just filled by 0. It's a plus sparse tensor. So this does that. Like what this we can see here, the sparse tensors. Value by index memory efficient. Okay. Sparse tensor, sparse tensor. This is 0, 0, 1, 2. Values. Dense shape. That is the main shape, which it is actually. which is cost x 0 now. So here we have completed the encryption to Tensorflow. So I think if we want, we can actually understand what is df of variable, what is that variable, what is df of what it does with execution also. What is eager execution? You can do all that, and we have to do automatic differentiation for computing graphs gradient technique. But this gradient technique is simply using gradients to maximize the performance. Then the production of graphs, the training and so on. So I think there should be enough for that. So this notebook, I hope you understood. Do you have some questions? If you have some questions, you have to leave the comments in the video.